Hello guys, and welcome to another episode of the Introduction to C++. Okay, in our previous tutorial we learned how to make a Hello World program and some of the basics of the C++ language. Today, well, first of all, if you guys are following along, you can go ahead and get last video's tutorial through my GitHub. The link should be posted in the description as always. Okay, so let's do this. So open up Visual Studio, and you can either create a new project just the same way as we did last time. For me, I am going to right-click on the solution, which is the topmost item in your Solution Explorer, and we're going to add a new project here, or at least I am. And we're going to make an empty project, and I'm going to call it IntroToCpp DataTypes. So we are going to be learning about what types, what different data types there are to represent different types of data in your program. Okay, let me go actually back here and just copy this header, which is going to be the same for most of our projects. And I'll just change the name to data types. And we'll change this later. Sorry. Okay. So we have a couple, well, several different data types. The first one that I want to talk to you guys about is the smallest data type we have, and it's called a char. This represents single letters, or ASCII characters. And if you have a group of characters, it represents a string, which we covered in the previous tutorial where we wrote Hello World to the screen. Character is 1 byte in memory, which is 8 bits. Did we go through this? I feel like we did, but no, I think I wanted to go over that in the last tutorial, but I just scrapped it. Okay, so the range of a character is 2 to the 8th, which is this. And why 2? Well, data in memory is binary, which is ones and zeros, which is base of base 2. That's why we have a 2 here. And since we have 8 bits, or 8 different combinations of ones and zeros, we do 2 to the 8th power, which would be around 256 characters. So if I do this, 2 to the 8th, 256. So that is roughly the size or the amount of data you can have. It does differ from being a signed. So we have signed data types, and then we have unsigned data types. The difference between these is signed means it can have negative numbers. And unsigned means it can only have positive numbers. Okay? So if we don't specify anything, if we just say car, is the same thing as saying signed char. So anything like this will automatically be signed. So this means that we have 256 different numbers that we can plug into this data type, from ranging from the negative to the positive. I'll just call it range. Okay, so this means that if we divide this by 2, the least is negative 128, and the most, meaning positive, is 127, because we have to count the 0 as well. So that's the range for this. The next one is a short, and this one is 2 bytes in memory, which is 16 bits, and the way you would get its the range would be 2 to the 16th power, because again it's base 2 and we have 16 different combinations of that. So that would be 2 to the 16th would be, let's see, percent 65 536. So the range is 65 536. So it goes from negative to positive, since it is signed. That means if we did divided by 2, the least, it would be 32 768 to 32 767, because of the 0. After this, we have our int, or integer. This is any number without a decimal. All of these are without decimal. And the size in memory here is, I misspelled bytes, 4 bytes in memory, which is 32 bits, which is 2 to the 32nd. The range, it is about 4 million. Let's just say about 4 million. And the, which goes to, since it's assigned, -2 million to +2 million. About that. Okay? Just say about -2 to 2 million. If you want to see the exact amount, it is a very long number. So there's 4,294,967,296. And if we divide this by 2, it is that. Okay? Now after this, we do have a 8-bit, which is long. If you do just one long, it is a 4-byte or 32 bits. If we do this, we get a 8-bit or 8-byte in memory, which is 64 bits, which is 2 to the 64, which is, let's see, 2 to the 64. Wow, that's very huge. And just say very huge. Okay, and then we have our Boolean, which I should really put a Boolean with the car, because it is also, this one represents true or false. And it is also 1 byte in memory, which is 8 bits. So it can only be 1 or 0, true or false. Okay. Then we have our float, which is 4 bytes or 32 bits. And this one does hold, this is a real number, which can hold decimals. I believe the number of digits, is it on the decimal side? Is it 7? I'm not sure, but it was 3 point something to the 32nd plus minus 32nd. So it is, and I believe it's only 7 digits. Then we have a double, which is the same as a float, meaning you can have decimals, but it is a 64-bit integer, floating value. and 64 bits. Okay, and this one can have about 15 digits. And that is all I'm going to cover for today. So these are signed, and then you can also have unsigned, which is from 0 to 255 if it was a char. Okay. So now let's create a little program. So we're going to include IOStream this time. And what this does is it gives us functionality like the other stdio to be able to print anything to the screen. Okay. Now, normally, if this is part of the std or standard library, and to print something out, you would say, you would first call the namespace, which is std for standard. Then you would do the scope operator, which is : and then the function, or what would that be called? Not sure. Okay, cout. Cout prints to the screen, and we use these shift operators to the left. Is it to the left? I think so. To be able to print out. And we will see if I am correct. Let's do that. Okay, if we do std : end line, that means it is the end of the line, end L. And it will automatically send you to the next line within the console. Okay. So let's pause it like we did before, and let's press F7 to compile it. Okay, and we have successfully built both programs. Now I'm going to make sure that the DataTypes is set to startup, because I forgot if we had it set, and then we're going to run it. Okay, so you see the same thing, hello world, and then we're waiting here for input, and you can see that yesterday the cursor was here, but since we have end line, we are now in the new line. Okay, so that's a different way of printing to the screen. So now let's create a couple of integers. So we're gonna have our int, and you wanna let's do addition. So let's do num1, okay, int num2, and then result. Now there's what I'm doing here is I am creating some variables. These are called variables. So I'm declaring variables of type int. And what is a variable? Well, hold on. Sorry. So um, a variable is, think about a variable as a container. So it's just a container that holds data for you. And with variables, kind of like in math, where you have variables, and I don't know, it's kind of like that, but we know what our variables are here most of the time. And we use them to store data so we can manipulate this data in some way. That's all variables are. Now, you do want to have a good naming convention. Whenever you create your variables, like this, num1, num2, and result. Well, result is good, but num1 and num2 aren't that great of a name. So whenever we are using variables, we would want to name them something meaningful. Okay? Name your variables something meaningful. Like if your variable is supposed to store health for a player or a position or whatever, you should name that what it is. Okay? But since I'm just going to be doing a quick addition or, arithmetic, whatever, we're just going to be doing this. Now when you create variables, you have two types or two ways you can declare your variables. If you declare stuff here outside of the main function, this is your global space. What this means is that if you were to have other functions, if you create, let's say you have this guy right here, this int num1 is now a global variable, okay? And what global variables are is that within the same file, if you have multiple blocks of code, these global variables can be used directly without being passed, and we'll talk about that more later on when we get to functions. But essentially, you'll be able to use this directly throughout your program or your file. Okay? If you declare them here, this is your local space, which is local only to the main function or to this block of code. Okay? So these would not be able to go into other functions unless they have a parameter that you can insert them into. And again, we'll be looking at that more later on. Now, it's always good when you declare it to also initialize. So this is being initialized now. Well, you can't do that here, obviously. Always initialize your variables to something before use. So let's say we want to initialize it to 0 or 10 or whatever. Another way you can initialize it is in the same line as the declaration. So this line will declare and initialize your variable all at the same time. Now, I'm going to run this program, and I'll just stop it right there. This is a breakpoint, so whenever we hit this mark, the program will halt, and I want to show you something. Now, what happens if we don't initialize our variables? Well, if we look here, if we hover over num2, you see that we have a negative 8 million or whatever. This is garbage. So if we try to use it, we can run into the possibility of crashing our program, and I'm pretty sure it will. But if we do this, you can see that the result is 0. And here we can see that num1 is 10. They actually have value inside of it. And this one doesn't. This is just garbage because when you initialize something, it might have in the memory, you might have some other memory there, and it doesn't know what it is. So it's just initialized to garbage. So that's why it's always good to initialize it. So let's see what would happen if we do this. And we get an error. Uninitialized variable num2 used. Okay, so you can't, in this instance of the program, it'll give you an error if you try to run it and then use it. But later on, if we use pointers, which we will get into later because they're more advanced, but if we do use pointers and we try to do it like this, we will crash the program and the compiler will not tell us about it until we crash it. Okay, so always initialize your stuff. Let's say 20. And let's put this guy right there. Okay, so now with this, we can do additions, subtractions, multiplications, and whatever. So let's say we want to, in result, we want to hold the sum of num1 and num2. Well, all we have to do is say num1 plus num2, and then instead of saying hello world, we'll just say result. And let's run it. And you see we get 30 because 20 plus 10 is 30. Okay, so that's one thing you can do. Let's do another one. Let's say you want to multiply them together. To multiply, you use the star. Not really sure what it's called, but okay. So now, when we get there, it should be 200 because 20 times 10 is 200. Let's put something here that'll tell you as addition. So let's copy from here to there and just paste it right there. We'll say multiplication And this one's going to be subtraction. Oh. So that's just the minus sign. So if we run it, we should get, well, oh yeah, that matters. We get -10 here because num1 is less than num2. And what happens when you subtract something that is less than the other thing? You get a negative. If we would do negative 20 minus 10, then we would get 10. So oh yeah, I'm gonna close this. So now we should get 10. Okay. Now, what if we want to have more than just one operation in there? Well, we can. Let's see. Let's call this. We'll worry about that later. So let's say we want num1 plus num2 divided by 2. Okay, so this is divided by. Let's run it, and we get 20. Now, why didn't we get 15? Well, because of the order of operations. Remember, if you remember in mathematics, division comes always first. So it'll be actually 20. Well, not there. It'll be 20 divided by 2 plus 10, which is 20, which is what we got. If we want to make sure that the addition happens first, we put parentheses around this. And now we should get 15. Okay? So make sure you use parentheses to make a something. Lack of words. Come before division. And this is true as well in math, because we have something called PEMDAS. What is this? This is parentheses, exponent, multiplication, division, addition, and subtraction. Okay? Now, if you want to be a programmer, you will be using a lot of math because all we handle is numbers. Kind of like an accountant. We just manipulate data to perform an action or whatever. Okay, so that's enough. I think that's enough for integers. Let's look at a car, a char. Let's call it, I don't know, character, or C for short. And we're going to initialize it to, I don't know, let's say 10. Why not? And watch what happens when we do this. Well, nothing happened. Let's see why. ASCII table. If you're working with strings and characters, it's always good to have one of these. And let's look at that. Well, 10 apparently is a new line. So if we wanted to do 0 or one of these numbers, it'll be 48 or greater. That's not it. So let's change that to, let's say, 55. And we should get, where's 55? Right there. We should get 7. Okay? And we did. We got 7. But you don't have to do this. In order for you to say you want A, you can, or if you can't do it with double quotations, it will give you an error. For chars, you want to do it with a single quotation. Okay? So A should be displayed now. And there you go. And what is A? A is nothing more than 65. So if we add, where was it? 32? Let me see. Yeah, 32. So let's say we want to make this guy smaller. Let's say we want to make A from a capital letter to a lowercase letter. Well, all we have to do is just add 32. Okay? Now, there's two different ways that you can do this. If you want to add to, the equal sign is called the assignment operator. So you're assigning whatever math value you get from the right side, you're going to store it on the left side. Okay? So if we want to add to 32 to C, what currently we have in C, we have to say C equals C plus 32. Now a faster way of doing this would be C plus equals 32. That is same thing as writing C equals C plus 32. Okay, and now we should get a lowercase a, and we do. So what if we have uppercase D? Well, if we add 32, we're going to get a lowercase d. Now what if we have a lowercase d? Would that give us uppercase D? The answer is no. It gives us something else, which I don't think it's in here in this. No, it's not. Probably some other table. But what would you would want to do is just say C minus equals 32, and then you'll get a capital D. Okay, so that's pretty much characters. Now Booleans. Bools are either true or false. Oh, we gotta name it. Let's call it B for Boolean. So they can either be 1 or 0. Okay? So if we print this guy out, we should be seeing a 1 or a 0. And true is 1. If we do false, that's 0. Okay? Just say 0. Now you can also say 0 or say 1, which is the same thing. So 0 is false, and 1 is true. Now let's see what else. Long longs, no, because they're the same. Shorts are the same. We went through bool, char, int. Let's do floats. Okay, this will be the last thing. Float. Let's call it, I don't know, real number. And let's say we want 152.5478. Sure. And we'll say the result is the real number times, I don't know, 0.97. Make sure that whenever you are writing float numbers, you put this in front of it. Otherwise, it's going to think, like right here, it says, warning, initializing truncation from double to float. So it's going to think, if you write it like this, it's going to think you're trying to place in a double instead of a float, and it's just stuff you don't need, you know. You don't need to be like telling you what's up, and then we have an error here. What is this error? Result redefinition. Oh yeah, because we already have a result. We'll just call it F result. Now there's a different kinds of naming conventions, or different types of naming conventions. Well, there's two really that I know of. There's Hungarian, which is the type followed by the name of the variable. So let's say you have an integer and you would want to name it I, lowercase I, and then, I don't know, number or something. This is called Hungarian. Now we also have something called Camel Case, which is much more popular, I think. And it starts off lowercase, like let's say you have, I don't know, number of frames or something. So we type it like this, kind of like, like the back of a camel, which is lowercase. Then the next word is the first letter of that word is uppercase, followed by lowercase letters. Then uppercase for the next word, first letter, and then lowercase for the rest. That is Camel Case. So these are the two main ones that people use the most. You can use whatever you guys want. I used to do a lot Hungarian when I was starting out because, it was simpler. It would let you know what kind of um, data type your thing was. But as I progressed, I kind of like Camel Case better, to be honest. Okay, so let's just do the print out of f result. And yes, this one is Hungarian. And we get 147.971. Yeah, so yeah, you can do different types of operations with different types of numbers. If you are trying to do, like if you have an integer and you're trying to do arithmetic with a floating number, and where you're trying to store this number is a float, like let's say we have f result and we're trying to calculate something like I don't know, real number times num1, which is an integer, right? We don't have to, but it's a good idea to cast it into the same type as this. So if these two were integers, then you would just encase them in parentheses, and then outside you would do float like this, and it would get this result, convert it into a float value, and then store it in this f result. So this is called type casting, which is very useful for many things. We'll get to that later on, and since these two are different here anyway, we'll just do the casting here, and we'll just print f result. Now I'm going to build it first, and see, we don't get any warnings or anything. But if I take this out and we build it, we should have gotten a warning. I guess we don't. Okay. But there you go. That's the number you get now. I'm guessing it automatically, doesn't matter because this one is. But let's say we have num2. Here we go. There we go. Okay. So let's build it one more time. Let's just delete that, go that, do that. See here, this line is what I was talking about. Conversion from int to float, possible loss of data. If you ever get that, you just have to cast the result into whatever data type you're trying to store it in. Then we build again, and that warning has gone away. And sorry, it's always good to not have warnings. At least I like it. I hate them for some reason. I'm not sure why. I guess I'm just a perfectionist or something. I don't know. Anyway, so that is all I want to cover today. We went over um, data types and arithmetic. Um, so I'm also going to add something here on different types of arithmetic. So you have, let's just put in a block. So you have addition, subtraction, multiplication, division. If you want to do division and get the remainder, it's called modulus, which returns the remainder of the. Actually, that's not the modulus. What am I talking about? That's the modulus. In some other ones, that's modulus. In some other languages, can't remember which ones. But that's the modulus. Okay, returns the remainder of the division of the operation, I guess. Okay, so if you guys would like to see how that works, then you guys can do it as an exercise. I'll leave you guys to that. You also have this one, which is, well, if you're doing, arithmetic with it, then this is your power or exponent. And yeah, that's pretty much it. So that's all we're going to cover today. I hope you guys had a great time here like I did, showing you guys the ropes. Yeah, so review it, memorize it, get better at it. This will definitely be helpful, like knowing the ranges later on as we deal with memory. But yeah, so I will be posting this up here soon, and I hope you guys enjoyed it. If you guys liked it, put a comment below. I also take suggestions of what you guys would like to learn next. And if you liked it, if you want to subscribe, that'll be awesome. More followers is always good. Okay, well, hope you guys have a great day. Bye.